Welcome. In this lecture, I want to go through what's called the difference of sets. The notation you're going to see a lot, and so but knowing exactly what it means, sometimes people haven't seen it. So we'll just go through that. So suppose that we have that A and B are sets. So A and B are sets. Okay, then by definition, okay, the difference, maybe we'll do the difference in green. So the difference of A and B, of A and B, is, so it's going to be a particular set. And what set is it? So, and also what is the notation for it? So the notation for it is going to be, let's box first. We know that we're talking about the difference of A and B, as this is what we're defining. And then we want to take, so we've got A without B. Okay, so what is this equal to? So this is going to be, by definition, so this is equal to the set of all. So we've got elements x, such that x is an A. I'll make it red because it's going to be an A. Okay, so elements x, such that x is an A. And x is not, so x is not going to be an element of B. Okay, so this is the notation. This is what it is. The picture, a lot of times it helps people to do the Venn diagram pictures because it's a nice visualization in your mind. So we have our set A, and we have our set B. And then what are we looking at? So we're looking at things that are in A but not in B. So we're looking at things that are in here, but we're going to exclude what's also in B. So we're just looking at what's right there. Okay, so this is the difference. This is the difference A without B. Okay. Now let's look at a really quick example. So example. Okay, let's take that A is going to equal 1, 2, 3. 1, 2, 3. And B is going to equal, oops, B should be in orange. I forgot I did that. I included some markers there in case my green ran out. Okay, so B is going to equal, and this is going, I'm going to look at this at 3, 4, 5. Okay, so how do I find the difference? So if I want to take A without B, so A, then we can even move this over a little bit. So that's the definition there. In fact, let's box the whole definition. So here's my whole definition. Okay, and then what do I get here? So if I wanted to take A without B, well, I want to take the elements, right, that are in A but not in B. So for each element, so 1, I look, is it in B? No, it's not, so I include it. I'm going to include these all in red because they all have to be in A. Now I look at 2. 2 is not in B, so I include it. I look at 3. 3 is in B, so I do not include it. Okay? So this is my answer. Right, so what did I do? I took each element, of A, so each element of A, and I included it only if it's not in B. Right, so I kind of threw out the elements that also were in B. Okay, so that's what I did there. And now the question is, how do you prove? So how to prove. Or disprove something about, so that if I want to take X is in A without B. Okay, so how would I prove or disprove this? Well, looking at this, this is actually an and statement. Okay, so I can just treat this like an and statement. The marker's not showing up perfectly there. Okay, so I'm just going to treat this like an and statement. Right? So to show that X is in, oh, I didn't realize, oh, okay. This is not in B. I didn't kind of realize my system here it's a little bit off of where it usually is. Okay. And statement. Right, so what do we mean by an and statement? So, right, to be in this, right, I have to satisfy both of these things. So I have to check, is X in A? So I have to prove that. Then I have to prove that X is not in B. So I have to prove that both of those are true if I want to show that it's true, right? If I want to show that it's not true, then what do I need to do? I need to, right, I need to show that it's either, right, because now we're going to be negating an and statement. So we either, we use De Morgan's laws, and we know that either, we need to prove that either it's not in A or it's contained in B, right? Those are the two ways that it could end up not in that set. Okay, so I hope that made some sense. It was helpful, and I will see you in the next lecture.